In this video, we're going to continue our talk about topic 5.1, which is mean value theorem. And earlier in the lesson, we mentioned intermediate value theorem. So we're going to take a look at really quick the differences and the similarities between intermediate value theorem and mean value theorem. So we know that intermediate value theorem is, its condition is that it has to be continuous, whereas mean value theorem has to be differentiable and continuous. So, but again, remember differentiability implies continuity. So what to look for is that we need to, is a conclusion about values of the function shown in the table that are missing in a table. And then what to look for here is a conclusion about the rate of change. So it's about the slope, rate of change of the function shown in the table. So if you look at the two problems, they are identical problems, okay? You'll notice though, but in this one, we've got a bug's velocity moving along x-axis, velocity differentiable, which means it's continuous, selected values given in the table. Is there a time c between 0 and 9 such that the velocity equals -1, whereas in this one it says the acceleration equals -1. Notice how this and this match. That's a sign of intermediate value theorem. Whereas this is one derivative up from this, that's an that's a mean value theorem. This one's intermediate value theorem. So the work that we would do is we would have, well, you can, if you state, you would want to state that is differentiable and continuous. So V is differentiable, which implies that it's continuous. So you can use these little arrows, that means implies continuous on 0 to 9. And then what we want to say is that V, so once I have that, I know the intermediate value theorem applies. So V of C equals -1 is between, so I have to look at where that is. This is the Y value. I know that the 1 is going to be between, -1 is going to be between these two values somewhere, because I've given those endpoints. So is between V of 9 equals -4 and V of 0 equals 5. So I definitely know that Y value is between there. Whereas on this one, we would say V is differentiable, which implies that it's continuous. So it's the same beginning on 0 to 9. And then we want to calculate the slope and show that that slope is on the graph. So we want to calculate the slope from these 2 points. So we would show that V of 9 minus V of 0 over 9 minus 0. And we know that it would be -4 minus 5 over 9. So it's going to be -9 over 9, which is -1. So what this shows is that we know that because the mean value theorem lets us, you know what I really should have said was, therefore IVT applies, and therefore MVT applies. So if MVT applies, I know that this slope is equal to the acceleration. So acceleration at C equals v prime of c equals -1. So the statements that we would write is we would write, since v of t is continuous on 0 to 9, the IVT guarantees that there is a time c for between 0 and 9 such that v of c equals -1. Whereas for mean value theorem, we would say v of t is continuous, is differentiable. I'm going to go with differentiable first. Is differentiable on the closed interval, open interval, 0 to 9, and continuous on the closed interval from 0 to 9, because there's a little bit of a distinction there. Therefore, the MVT guarantees that there is a time c for between 0 and 9 such that a of c equals v prime of c equals the slope equal to -1.